Hi Year 10, welcome to your weekly introduction video. This week we're learning about angles. Most of what we're going to be doing this week, you already know, it's very easy, so just a bit of practice. Okay, so here is two questions just using some very basic angle rules. So stop the video, have a go at them. Should be straightforward, but of course if you need help, you know that you can just ask. Okay, so hopefully you did that. So question E, all we've got to do is make an equation really. We know that we've got angles on a straight line here. Angles on a straight line sum to 180 degrees. So x plus 15 plus 4x minus 35 must be equal to 180. Okay, so now simplify the left hand side. 5x minus 20 equals 180, and throw the minus 20 to the right hand side. 5x equals 200, and divide both sides by 5x equals 40. Okay, that should be pretty straightforward. Okay, some things to note with F. First things first, this line and this line are parallel to each other. The arrows are telling me that that is the case. And this line and this line are the same distance. The dashed lines are telling me that that is the case. They are the same length. So we actually know this is an isosceles triangle. Okay, which means that this angle is also 42 degrees since it's isosceles. So y plus 42 plus 42 is equal to 180 because the sum of interior angles in a triangle is 180 degrees. So y plus 84 is equal to 180. So y is equal to 96 degrees. Okay? And if y is 96 degrees, then so is x. Okay, why? Because we've got that F shape with parallel lines, so angle y and angle x are corresponding angles, and corresponding angles are equal to each other. Okay, so that hopefully was a very easy start for you. Any confusion there, do let me know. Now, so what we're going to look at now is angles in interior and exterior angles in polygons. Now, we've already done this investigation before, so I'm not going to ask you to do it again. I'm just going to quickly remind you how it's done, so that we can remind ourselves how we find the relevant formulas for interior and exterior angles. Okay, so let's name some of the polygons that we've got here. Well, we've got a triangle, we've got a square, we've got a pentagon, okay, we've got a hexagon, and we'll do a heptagon, 7 sides, and we'll do an octagon, 8 sides. Okay, let's just have a reminder of what an interior and an exterior angle is. Well, an interior angle is the angle inside the polygon, and an exterior angle is the angle outside the polygon, but only up to the straight line that's continued from the interior angle. Okay, so one important thing to note is, because it's a straight line, an interior angle plus an exterior angle must be equal to 180 degrees. So that's going to be useful. Okay. Now, what we can do now is set the number of sides. Okay, so triangle has 3 sides, square has 4 sides, pentagon 5 sides, 6, 7, 8 sides. Okay. Now, what we can do to try and make this easier is to try and split all of these shapes into triangles. Now a triangle is just a triangle, so a triangle represents one triangle. A square we can split into two triangles. Okay? A pentagon we can split into three triangles. Okay, and a hexagon, four triangles. And obviously we can see the pattern. A heptagon, we're going to be able to split into five triangles. And an octagon into six triangles. Okay. Now you should remember some basic facts. The sum of interior angles of a triangle is 180 degrees. And the sum of interior angles of any quadrilateral, including a square, is 360 degrees. And actually the sum of interior angles always has 180 degrees added to it as we increase the number of sides by 1. So this is what it will look like. Okay, 900, 1080, we'll be adding 180 degrees each time. Okay, so if we're talking about a regular polygon, that is a polygon with equal side lengths and equal angles, then all I need to do to find one interior angle is do the sum of the interior angles divided by the number of sides. So that's going to be 60 degrees is one of the angles. That's going to be 90 degrees. That's going to be 108 degrees. That's going to be 120 degrees. Heptagon's going to be a weird number. It's going to be 900 divided by 7, which is to one decimal place 128.6 degrees. We always do angles to one decimal place unless told otherwise. And then an octagon, divide that by 8, it's going to be 135 degrees. Now remember what we just said, an interior angle plus an exterior angle must be equal to 180 degrees. So the exterior angle here must be 120 degrees for a triangle, okay, 90 degrees for a quadrilateral, or a square rather, 72 degrees for a pentagon, hexagon will be 60 degrees, heptagon will be 51.4 degrees to one decimal place, and octagon will be 45 degrees. So if we want to find the sum of exterior angles, I'm simply going to do the number of sides times one exterior angle, which is 360 degrees. 90 times 4 is 360 degrees. 72 times 5 is 360 degrees. 60 times 6 is 360 degrees. Hopefully remember that fact, that the sum of exterior angles for any polygon, no matter whether it's regular or irregular, is always 360 degrees. And that kind of makes sense because if we look at the triangle over here, all we're doing is going round in a circle, and a circle has 360 degrees in it. So what if we now said, what's all this information for an enagon? An enagon, a polygon that has n sides. Polygon that has n sides, okay? What's the number of triangles in it? The number of triangles is n minus 2, because you can see that the number of triangles is always 2 less than the number of sides. 2 less than the number of sides, so n minus 2, okay? And the sum of interior angles is always 180 degrees times the number of triangles. So it will be 180 times the number of triangles, which is n minus 2. Okay? What's the size of one interior angle? Well, it will be 180 times n minus 2 divided by n number of sides. Okay? Should be fairly easy, that. The sum of exterior angles is always 360 degrees, no matter what. So that's just going to be 360. What's the size of one exterior angle? Well, that means it's just going to be 360 degrees divided by the number of sides, provided that this one here And this one here, these formulas are only true for regular polygons. Okay, for irregular polygons, wouldn't necessarily be possible to know unless you had additional information. Okay, so we did that before, and that's how we derived each of these formulas. Okay, so the sum of interior angles is equal to 180 times the number of sides minus 2. The sum of exterior angles is 360 degrees. And these are for any polygon. For any polygon, okay? The size of one interior angle is 180 times the number of sides minus 2 divided by the number of sides. And one exterior angle is 360 divided by the number of sides. These are not for any polygon. These only work for regular polygons. So, just to make that clear, this is for any polygon. And this is only for regular polygons. Regular polygons. Okay? And don't forget the very, very important formula that says that an interior angle plus its partner exterior angle is equal to 180 degrees, because they always make a straight line. Okay? So hopefully that makes sense. Hopefully, it's just revision. It's stuff we've done before. Okay? So we've got the formulas there. All we need to do is use them. So here we've got a question. Calculate the number of sides of a regular polygon with these interior angles. I'd like you to stop the video and have a go first and see if you can do them. Okay? Okay. There's two ways to do these, okay? What I would do is say, okay, we've got the size of one interior angle in a regular polygon. So which formula are we going to use? Well, we need to use this formula here. One interior angle in a regular polygon. So let's write down that. The interior angle in a regular polygon is 180 times n minus 2 over n. Okay, well, let's put in what we know into this equation. We know that the interior angle is 120 degrees, but we don't know n. And let's expand the bracket. So that's going to be 180n minus 360 all over n. So now we've got an equation we can solve. All we need to do is multiply both sides of the equation by n. Okay, it's just a linear equation. Should be nice and easy. 120n equals 180n minus 360. Now we're going to subtract 180n from both sides. So negative 60n equals negative 360. Now simply divide both sides by negative 60. And a negative divided by a negative is a positive, so n is equal to, not 60, n is equal to 6. Okay, n is equal to 6, and that's the answer. So this one must have been a hexagon. Okay, I'm going to do B in a different way. Okay, I'm going to use the formula that says the interior angle plus the exterior angle equals 180 degrees. So if the interior angle is 150, the exterior angle must be equal to 30 degrees. So I now know the exterior angle, so I can just use this formula here and say exterior angle equals 360 divided by n. So the exterior angle is 30 degrees. And we don't know n, so what we're going to do is multiply both sides of the equation by n. we get 30n equals 360. Now divide both sides of my equation by 30. So n equals 12. Okay, so this must be a 12-sided shape. Okay, let's just do the answers to the other two. That would be this one will be a 360 divided by this would be a 72. This would be a 72-sided shape. Okay, and this one would be a 360-sided shape, regular polygon. Okay, hopefully that makes sense. Any problems, let me know. Okay, here's a slightly trickier problem. I don't think it's beyond the realms of your ability to do it though. So stop the video and have a go. Okay, first things first, it says find the size of, it's a regular heptagon, find the size of each interior angle, and then find the value of each unknown, okay? Now I'm just going to teach you some letters here. These are Greek letters. This is alpha, okay, it's alpha. This is beta, okay, this is Greek letter for B, alpha is the Greek letter for A. This one here is what we call lambda. Don't really need to know these, I'm just telling you, okay? And this one here that looks kind of like a D is delta. So when I'm talking about them, you know what I mean, okay? So first things first, let's do A. A is a nice easy question. It's simply find the size of each interior angle. So the interior angle in a regular polygon, which this is 180 times n minus 2 over n. So that is equal to 180. It's a 7-sided shape. So times 5 divided by 7. And I'm just going to use a calculator. 180 times 5 divided by 7. And to one decimal place, I'm going to get 128.6 degrees. Again, always use one decimal place for a angle unless the question says differently. Okay, so that tells me the size of each interior angle. Right, now we've got to find the size of the unknown. So I'm going to start by finding alpha and beta. And what I do first is I recognise that what have I done here? I recognise that this is a triangle. Let me just use a highlighter. This is an isosceles triangle. Okay, because it's a regular polygon, what that means is this side is the same length as this side. So that means this angle is also alpha. And I already know what the interior angle is. It's 128.6 degrees. So I know 2 lots of alpha plus 128.6 degrees is equal to 180 degrees, the interior sum of a triangle. So 2 alpha equals, let's just use a calculator, 51.4 degrees. And so alpha equals, let's divide that by 2, 25.7 degrees. Okay, that's alpha. And I also know that alpha plus beta makes one of the interior angles. Okay, so alpha plus beta is equal to 128.6 degrees, one of those interior angles. And I already know alpha, so 25.7 degrees plus beta is 128.6 degrees. So subtract 25.7 from both sides. And I get an answer of beta is equal to 102.9 degrees. Okay, so there's alpha and beta. So let's just clear some space now. Okay, we now need to find lambda and delta. Lambda and delta. Okay, so how are we going to do that? Well, what are we going to do here to find lambda and delta? Well, I suppose I know that this is also beta, okay? And since everything here is parallel, okay, this line is parallel to this line, it stands to reason that this is also lambda degrees, okay? So I think 2 beta plus 2 lambda is equal to 360 degrees, the sum of interior angles in a quadrilateral, okay? And I already know beta. Beta was 102.9 degrees, so 2 lots of 102.9 plus 2 lambda equals 360 degrees. So let's just work out what that is. That's 205.8 degrees plus 2 lambda equals 360 degrees. So 2 lambda, let's take 205 from both sides. Okay, I get 154.2 degrees. So lambda, just divide both sides by 2, equals 77.1 degrees. And again, I know lambda plus delta is equal to the interior angle, that is 100, what is it again? Hang on, so I've forgotten. 900 divided by 7, 128.6 degrees. Okay, lambda I already know, 77.1 degrees plus delta is equal to 128.6 degrees. So now take away 77.1 from both sides, and I get 51.5 degrees for delta. Okay, so I've found each of my unknowns. Okay, alpha, beta, lambda, and delta. Right, now, because this is a fairly easy topic for you, one that you know and it's not that difficult in the first place, this week I'm giving you a challenge, okay? I recently read a book about why it is that some students are successful at learning maths and other students are not. And it seems the research tells us that the sole difference is students that give up easily don't do very well. Students that persist and find the joy in solving a difficult problem, even though it takes time, tend to be very successful. So I want you to have a go at this and to not give up, okay? And the other reason why I want to have a go at this is kind of the kind of stuff that you will get on a paper 6 exam, okay? It's more investigative and open-ended questions. It won't be quite as difficult as this because a paper 6 exam, the questions will be staggered and built up. Okay, it won't be just one question that's difficult to do. It'll be a whole difficult question with a series of steps to help you get there. But that means if you can do this without that, you're really doing very, very well. Okay. So what I want you to do, and I'm not going to tell you the answer to this. I'm going to do a separate video, or maybe do it live. I'll decide later to give you the answer. But I want you to submit your solutions to me on Teams. Okay. So what you've got to do, you've got to find the sum of the angles at the points of a 7-point star. So what I mean by that is find the sum of this angle, this angle, this angle, this angle, this angle, this angle, and this angle. Now, I am not asking you to find the size of each individual angle. You couldn't actually do that. There's not enough information in the question. But you can find the sum of them. So what I'm asking you to do is find the P plus Q plus R plus S plus T plus U plus V without actually knowing what they individually are. Okay? You don't need to know the size of them. Now I'm going to give you a little hint to get you started. Okay? What you want to do is, let's start labelling the interior angles of the central polygon. And we're going to call this one angle A, angle B, angle C, sorry about that, angle D, angle E, angle F, and angle G. Okay? So that, we should be able to start making some statements about what we've got there now. Now, if you're finding it difficult, which you possibly will, the first thing you need to do to help yourself is leave this and go to the MyIMath assignments, do them first. And there's one MyIMath assignment called Angle Proofs. Okay? Go do that MyIMath assignment first. It may help you with solving this problem, okay? If you're still completely stuck and you need a bit more help, then just come on the call and I will give you more hints and a bit of guidance, okay? So I don't want you to sit there and struggle and not be able to get anywhere, but I do want you to not give up and persist and see if you can actually do this, okay? As I said, it'd be very helpful for when you come across paper 6 style questions, okay? So that's your intro video. If you've got any problems at all, come on the call and let me know.